HEVC, and I want to kind of bring you up to date on where I see HEVC is from a deployment standpoint, and that's the first 3 points, and then we'll look at some very specific encoding parameters to use when encoding with X.265 and main concept. So we've got an hour, and probably won't take all that, but we'll see where we end up. Point one, you know, the HEVC, like H.264, is a patent encumbered technology. So if you want to deploy an encoder or decoder, you're going to have to pay for it once you get beyond certain de minimis amounts. And the first patent group that came out with license terms was MPEG-LA, and these came out late last year, late 2014. And their terms were 20 cents per encoder decoder, but only for shipments in excess of 100,000. So if you want to build your own encoding tools with X.264, you're free to do so until you get to 1,001 or 100,001. If you are paying an encoder or decoder royalty, there's a $25 million annual maximum for the first year. So who's that going to apply to? That's going to apply to Apple. That's going to apply to all the cell phone manufacturers. It's going to apply to chipset vendors for on the encode decode side, primarily decode for set-top boxes and for system on chips for mobile and for devices like that. There was and is no content royalty under the MPEG-LA HEVC plan for HEVC, and that's new because with H.264 there were the potential for royalties, and still are the potential for royalties, for pay-per-view or subscription content. So one of the big questions with HEVC from the MPEG-LA perspective was there going to be content-related royalties? And MPEG-LA came out and said no. The only problem is the second pool announced on March 24, 2015. So MPEG-LA came out again with their terms at the end of 2014, and another royalty pool called HEVC Advance came out on March 24th, and it included some pretty big companies. It included GE, Technicolor, Dolby, Philips, and Mitsubishi Electric. So these are not companies to be trifled with. The group itself, GE says they're, it's totally independent from General Electric, but the head guy is a GE employee. So they say they're going to go out and get staffing from a number of other companies, and it's going to be an independent company, but the ties to GE were pretty evident when we first heard about them. And their goal is to let their general terms be known by the end of Q2 2015, which is in a month or so, and to offer licenses by Q3 2015. So at this point, we don't know if there's going to be any content licenses at all. And we don't know what their royalty terms are going to be. There are some limitations set by fair and reasonable patent policies where the 20 cents can't really go to $2 or $20, but we don't know what the final terms are going to be. The other point is there may be lurkers out there. There's no guarantee that HEVC Advance and MPEG-LA has all companies that have HEVC related IP. So if you licensed H.264, you wrote checks not only to MPEG-LA but also to other companies. So there is the possibility that there are other companies out there who may arise once HEVC usage becomes more common. So the big question, of course, is what's that mean for the market? And it's kind of my first attempt to get a laugh. That didn't work. Nothing freezes a market like uncertainty. One of the biggest potential markets for HEVC is to reduce your bandwidth costs because you can cut data rates by up to 50% and maintain the same quality as with H.264. But if you're using a technology like HEVC to reduce your bandwidth costs, you need to know what it's going to cost from a content perspective. The encoding costs are pretty well known at this point, but if there's going to be a royalty on the content, you need to know that before you can put those plans into play. So I think it's going to have a, this is the best picture I could come up with for a chilling effect on the market. But it's only going to be for a few months because we should know what their plans are by the end of June, which is just next month. And I don't really see that slowing down any of the relevant market spaces. I mean, the encoding vendors have been full speed ahead since HEVC was finalized. I think that was last January. So pretty much every enterprise encoder out there has HEVC. Most of the prosumer, Telestream episode class or Sorensen Suite class, they've had it for a while. It's only the compressor / Adobe Media Encoder types that don't have it. So pretty much every encoding tool you're going to use in an enterprise role has had HEVC encoding. On the decode side, for the last 6 to 12 months, most chips were, certainly had it in the product plan, and you would expect that to continue, and it has. From a content perspective, there's only a few companies putting out HEVC related content, the 4K stuff, but they're doing it very loudly. And that's Netflix, Hulu, Amazon, and other, movie subscription services for 4K content to play back on OTT devices or smart TVs. Very limited market. There's a very small group of publishers who are in that market, but that is the most important market certainly for 4K, and probably HEVC at this point as well.
Can you define what you mean by set-top box? I mean, I know what it is, but what context do you mean it in?
Set-top box would be a device that you connect to a television to play back audio and video.
Comcast, Time Warner, DirecTV, all of those?
Yeah, I would think that most of them are, Avni Rambia is an analyst for Frost & Sullivan, and she gave a talk yesterday. Were you in there? So, just what she said. She said that even if the chipsets aren't turned on, even if they're not advertising that they have HEVC, the additional cost of adding HEVC to a system on a chip at this point is pretty modest. So if you're a manufacturer and you know it's coming even in 2 or 3 years, you probably want to include it on a chip today. But it's a good question. I mean, I guess I would feel very comfortable saying that everybody's got it on the product plan if it's not implemented already. Okay, so that's the royalty status. The big question about HEVC that everybody had to have when it first came out is, the promise was same quality as H.264 at half the data rate. So that was kind of we knew 2 things about HEVC. It's, same quality, half the data rate, 4K. Those are the only 2 things you really needed to remember. And the big question up front, when it first came out in, the first test I did in November of 2013, HEVC wasn't quite there. So the files that they produced weren't the same quality as H.264 at half the data rate. And now, looking at probably the 3rd or 4th generation of X.265 encoders, we finally gotten to the point where they're delivering on that promise. So what I tested, I had 3 files. One is an animation, the Blender movie Sintel. And animation is kind of a separate concept, right? It compresses differently than real-world videos because it's all synthetic, a lot more inter-frame redundancies. And then a movie trailer, which was Tears of Steel, and then a real-world video. And the real-world video is 10 or 12 5-second sequences of various content from talking head to very, very high motion. So that was kind of my real-world test clip because I think movies are a bit synthetic as well. A lot of depth of field, pretty easy to compress. So I wanted to try real-world clips as well. And I encoded at 720p at 2 megabits per second and 1080p at 4 megabits per second. And then I compared it to 720p at 4 megabits per second and 3 megabits per second. So it was 200% and 150% of the data rate. And 1080p at 8 megabits per second and 6 megabits per second. Again, 200% and 150%. And then I assessed the quality with the Moscow University Video Quality Measurement Tool. And you can, there's a URL that you can see or just barely see on the bottom of the slide. Anybody back there can adjust this projector? It's cutting off the, you guys probably aren't the projector guys, right? Okay, that's okay. This is not available on our website. As I said, Microsoft decided to hijack my machine 15 minutes before the session, so I couldn't get it uploaded. But I will upload this to my website at streaminglearningcenter.com, and it'll be up there before the end of the day. So sorry it wasn't up there before this session. Anyway, so I ran 3 different types of files, 2 different configurations, and then the Moscow University Video Quality Measurement Tool gives you an objective metric of quality. So it's they offer SSIM, they offer PSNR, they also offer something called VQM, Video Quality Metric, which is the one I like the best. That's the one I use in the comparisons that I do. And the thing to know about VQM is that lower scores are better. So, yeah, it can't be that hard, right? You got to get the logo in. Just kidding. But here's the... Okay, so if you want to, here's a review I did of the Moscow University Video Quality Metric Tool. And basically, you put in your source file, you put in your comparative files, and then it spits out a number. And that number is a gauge of quality, like PSNR is, like SSIM is. And again, lower scores are better. So X.265, and this is the most recent version of X.265. I got this last Friday. And so I encoded at the data rates we showed on the slide previously, and I guess I can't walk around. And this is H.264 at 2x the data rate, and this is H.264 at 1.5x the data rate. So in the 2 real-world files, the new file, which was my synthetic test file, and Tears of Steel, the quality of X.265 was the same or better than the same quality at 2x the data rate with H.264. So that means that HEVC produced the same or better quality as H.264 twice the data rate. And it didn't quite get there with the animated files. And if you know anything about X.264, you know there's a tuning for animation. And I used the tuning for animation. There isn't an equivalent tuning yet for X.265, so I can't say if we're going to get there, but that's probably responsible for the difference. And the miss percentage shows how close we were to same quality at twice the bandwidth. So we missed by 16%, 17% with the 1280 clip, and about 7% for the 1080p clip. And then at 1.5 times the data rate, the X.265 clips were the same quality or better. So if you're working with real-world videos, I think it's pretty reasonable to assume that you're going to get same quality as H.264 at half the data rate, which was what HEVC has been promising all along. And that number's only going to get better. Codecs mature, they get better with age, and we should see that happen with HEVC over the next 2 or 3 years at a pretty good rate. So again, when I first did this a year and a half ago, we weren't anywhere close to this. HEVC is really moving forward in terms of delivering what they're promising. And then here's kind of the summary that I just said. So if I was planning on distributing animated content with HEVC, I would run some tests beforehand. I'm pretty confident that with real-world video, you should be able to see similar results. And then where will it play on computers from how much CPU horsepower do you need to play back HEVC? These are pretty old computers for the most part. I mean, the Dell Precision is, I think it's from 05. The Mac is from 09. The EliteBook here, this is actually pretty current. This is about maybe 2012. So I use old machines because, old machines and old slow machines because it's going to run fine on really fast machines. So on the Precision, which was the first Core 2 Duo, 720p HEVC plays fine. And it fails totally with HEVC, although it does play H.264. So you can tell from these statistics that if you have computers out there that are barely capable of playing H.264, they're not going to play H.265 successfully. On the other hand, if you move to a 2009 class Mac, the percentages go down, although it still did fail at 1080p. So I think 720p video, I feel pretty comfortable saying most relevant computers out there can play it. And then once you get to the i7 class of computers, and that's this notebook here, then you can play 720p, you can play 1080p. And I kind of differentiate, 720p, 1080p, I kind of test that because those are the configurations you would use if you wanted to replace H.264 and save bandwidth, as opposed to 4K, which is kind of a totally separate market. It's primarily OTT, and it's not really savings, it's opening up a new market.
What decoder were you using in that test?
Good question. I was using VLC.
And how long has that been available on VLC?
VLC came out sometime before November of 2014. I don't know the exact date.
Okay.
So there's a couple players you can try. VLC player, happily non-compliant with MPEG-LA's royalty policy, but a wonderful tool for people who are in the business. That will play HEVC video, and the other one is DivX will play HEVC video. And you really do need both of them because some files won't play on one, will play the other. The other tool that I've used a lot is the Vanguard video player, and that's a comparative. That gives you the ability to compare one file versus another, which is a very useful analysis tool. So those are the three that I use the most, and I tested on VLC. So the big question from a mobile perspective is, not only will it play, but what's the impact on battery life? So this was a test done by the magazine TechSpot, where they encoded video using H.264 and HEVC, and then they measured battery life for movie playback on a number of particular devices. And what they found was that HEVC playback cost you about 50% of your battery time. So whether or not that's significant in the context of who your target market is, that's kind of up to you, but it seems like it's a pretty significant number. What Avni said yesterday is she thought this, you wouldn't see any improvement on this number, and she's seen some players under NDA that she says will allow longer playback without affecting the battery life as much. She's seeing software decoding and software playback is becoming more efficient.
So is this on mobile devices that don't necessarily have hardware accelerated support?
Great question. Great question. Should have specified that. This is so we're moving from an environment where none of the mobile devices had hardware acceleration for HEVC, and now we're moving into an environment where some of them do. And if you do have it, you should expect to see very little battery life degradation. These tests were performed with devices that did not have hardware decode. Which devices out there have hardware decode now? I mean, we're going to cover this in a second. Pardon?
The high-end Android, the new Androids.
That's right, the new high-end, the 5.0. Well, they all have software, but I'm not aware of any that.
I'm not sure anyone knows what royalties to pay for a hardware embodiment.
But I was talking here with somebody from Qualcomm, and they said that
Right.
that the chips that were in several of the high-end ones do have hardware decode.
That's right.
Built in them.
Yeah, but those, Android 5 came out within the last couple of months, so I don't have any of those devices, I haven't run any tests, but great question, great point to bring up. And then here's, so that's the playability side. There's multiple aspects to playability. There's will the file play? Can you get 1080p playback? And obviously this guy did. What's the implications of the battery life? And then the last piece of the puzzle, which is really the most challenging, is there software that can play it back? I mean, it's okay for me to use the VLC player on my computer for my tests, but if you're distributing, if you're PricewaterhouseCoopers and you're trying to send it out to 100,000 people, you can't rely on open source free software that violates, MPEG-LA's royalty. I mean, you've got to, is the software out there that's going to play your video for you? And that's where things on the computer side are really falling down. So you've got DivX, and They've got an install base of over 10 million, which is an impressive number, but it's nowhere near ubiquitous. VLC Player, they're not talking. I don't know how many versions they have. There's a lot out there, but again, it's not ubiquitous. And then Adobe, they've announced that they plan to do HEVC code in the Primetime platform, which is their premium distribution platform, but not in the free Flash player. Why? Because if the free Flash player, they'd have to pay the $25 million maximum royalties, or whatever it's going to be after HEVC Advanced gets their share. Whereas in Primetime, the number is going to be a lot smaller, but they'll be able to charge that for their customers. So, you know, what really made H.264 happen was it was picked up in Flash, and within a couple of months, every computer and laptop could play H.264. That dynamic is not anywhere close to happening for computer and notebook playback on the desktop. So it's a very big difference between what happened with H.264. And then what about the browsers? Well, within Apple, this is a bit bizarre. They added HEVC encode decode for FaceTime, but they didn't include HEVC playback in the browser, or in, I guess Safari is kind of the media player on the iOS platform. So if you're doing FaceTime with another iPhone 6, you're sending HEVC encoded video, but you can't play a file that you download to your iPhone that's in HEVC format. Why would they do that? I mean, I have no idea, but that's how things stand today. And there's no word on the Safari or on the Macintosh. You know, again, the royalty status that we looked at, there's a $25 million cap. Not that that would be a significant number for Apple anyway, but it's going to be even less significant if they end up paying the maximum because they ship 125 million iPhone 6s. So you would think that once they pay the maximum royalty, they would just include it everywhere, but they're not even including it on the devices that they're paying the royalty for. So I don't really understand that. But you would think in the next, the next 3 to 6 months or 6 to 12 months, whatever the time frame is, that Apple would introduce HEVC playback on the Mac, on the iPhone, and kind of open that up. Okay, so how's VLC and DivX? DivX is paying, I'm sure, paying or reserving, and VLC is just a French company, and they say patents don't exist, so we're not going to worry about it. And I think they're, I think MPEG LA, whatever their strategy is, they're just not seeing it as significant enough to go after them. I know, but that that does you well for your own use. But again, if you're a big company, if you want to distribute HEVC encoded video to a big audience, you can't tell them all to download. You can if it's 10 or 15, but if it's and also if you're an enterprise, you can't tell people to download software that's illegal. So it's a pretty fringe solution. It's great for kids who want to do their own HEVC movies, but it's not a practical solution for broad-based distribution. And then, as we talked about, Google added software decoder and hooks to HEVC hardware decode in Android 5. Some HEVC capable devices were announced. I haven't played with any. I think I have a slide in here that talks about what the installed base percentage is. Android 5 is currently up to about 10%. So 10% of Android tablets and phones who are running Android 5 should be able to decode HEVC files. I haven't tested that, but I don't have an Android 5 device. Again, no word on Chrome. Google is not paying the royalty on HEVC decode for all the Android devices. It's up to the, Samsung is paying it for the Samsung devices that it ships, and Sony for the Sony devices. You would expect that Google is going to ship enough Chromecast and the products that they sell, enough of those to hit the maximum sometime soon. So it wouldn't be shocking to see HEVC-related decode appear in Chrome sometime in 2015 as well. And Google has been pretty predatory about Chrome, especially vis-a-vis Firefox, if you wanted to be kind of cynical about it. I mean, they've really, so they've taken a lot of market share away from Firefox. Mozilla doesn't have the cash to license HEVC, and I wouldn't be surprised if Google spent the $25 million just to further degrade the market share of Firefox as related to Chrome. they've been very aggressive with their browser, and it's doing very well. So I wouldn't be shocked to see them go in that direction. And then Microsoft is committed to including HEVC decode in Windows 10, which will ship in 2015. But they've done very little to bring that back into previous Internet Explorer or Windows versions. As an example, media source extensions, which is necessary for HTML5 playback, is only available on Windows 8.1, Internet Explorer 11. So I would not expect Microsoft to make HEVC decode backwards compatible to previous versions of Windows, which means HEVC decode is going to be slow growth. It's going to be totally tied to Windows 10. And then Firefox and Opera, Firefox actually makes a surprising amount of revenue. I mean, like 80 to 100 million, which is, you'd think it's a tiny little company, but a lot of that came from Google, and a lot of that's going away now. But they didn't make the kind of cash to spend 25 million on royalties to MPEG-LA. So, and then Opera's even smaller than Mozilla. So I don't see these two browsers ever licensing HEVC. What was interesting about Firefox is Firefox picked up H.264 decode from the operating system. So once it was available on the Mac and once it was available on Windows, they were able to tie Firefox in so they could access the H.264 decoder in the operating system and play it that way, which was pretty smart. But we're not seeing HEVC decode on the operating system for the next, potentially long period of time, especially on the Microsoft platform. It could be a lot quicker on Apple, but I don't see it on the Mac. I don't see it broad-based Microsoft until Windows 10 becomes pervasive. And then, just to kind of sum it up, where are we today? VP9, which is obviously a competitive technology to HEVC, is playing on. It plays on Chrome, it plays on Firefox, and it plays on Opera. So just counting Chrome and Firefox, it's playing on 59% of browsers today, and HEVC is playing nowhere today, other than the mobile platforms that we talked about. Nowhere in general computers, nowhere in notebooks. So it's really striking how little progress has been made in terms of browser-based playback. I think HEVC is very concentrated in set-top boxes, smart TVs, and that's it. Whereas the big announcement this year, Google said they pumped out 25 billion hours of VP9 encoded video in 2014, April to April. So UHD codecs are successful. They're just UHD codecs not named HEVC. And then here's the chart that I talked about a few minutes ago. This is a great resource. I've got the URL here, and that gives you a dashboard as to which version has which market share. So we see that Lollipop 5.0 and 5.1 is 9.7%. That's the 10% number that I talked about a few minutes ago. VP9 playback started in KitKat, which is 4.4. So VP9 playback on Android is essentially the 40% for KitKat and then the 10% for 5. So you've got VP9 plays on 50% of Android and plays on 10% of Android for HEVC, although I see that number increasing rapidly. Google does a pretty good job getting new operating systems out to computers or devices that are compatible with it. And then, not really quite sure what this picture is supposed to mean, but it's the one Google put out when they announced the 25 billion hours. And their pretty bold announcement that VP9 is the most efficient video compression codec in widespread use today, and that is absolutely true. So kind of a summary, I think from a desktop and notebook perspective, the files could play. You can play 720p encoded HEVC video everywhere and save a lot of bandwidth if you were paying for the bandwidth to deliver to those computers, but there's no pervasive player you can count on to be there. On the mobile, you've got the battery and power issues for the vast installed base of devices that are out there. And there's a substantial percentage that will never play HEVC. unless you're a totally greenfield installation, you're never going to be able to drop support for H.264. When I say never, I mean certainly the next 2 to 3 years. So, from an HEVC perspective, streaming to desktop and mobile devices has seen very little progress in 18 months. The codec's gotten better. It's gotten much more widely supported on the encoding side, but it's not in use because there's no players. And, 215 should be a good year. I mean, Google should add it to Chrome. Apple should make some big announcement, but that's all guesses on my part. And then, so that's all computers and mobile. That's one market. The market, as I said, that HEVC has been most successful is OTT and smart TVs. And we're still looking at very, very, very tiny numbers. So here we're seeing 1.3 million sold in 2014, 4,000 to be sold in 2015. These are numbers from the Consumer Electronics Association. Those are just really, really tiny numbers. And also, I see OTT and streaming as being very different. There's a lot of publishers who care only about streaming, never really care about OTT. Most OTT producers are probably going to care about the streaming installed base as well, but there's a lot of publishers who just never care about if their videos can play on Roku, or they don't care quite as much as a Netflix or Hulu would. And then the other thing about 4K TVs is that I think that picture is changing rapidly. I think it's pretty established that any 4K TV sold before like 2016 is going to be obsolete in 2016 or 2017. And I asked Avni, the analyst from Frost & Sullivan, yesterday, I said, what impact is that going to have on HEVC and 4K TVs? And she goes, well, they're pretty much obsolete. There's nothing to play on them anyway. So I mean, the people who bought them had to realize that. So it's no big deal that they're going to be going away. I'm not really sure how this is going to affect things, other than I'm certainly not going to buy a 4K TV because I'm not going to spend $800 on something that's not going to have, it's not going to have HDR. It's not going to have some of the newer advances that are going to be coming out in 2015 and 2016. And these are, this is not my opinion. This is CNET, Forbes. This is an article from Huffington Post. Actually, the gentleman who wrote it was in my last session. And he tells you about HDR. HDR is just a better way to, like you see on your iPhone, when you shoot in HDR, you get better depth, better contrast. And TVs are moving in that direction, but it's substantially likely that any TV that was bought before this is enabled won't be able to see that benefit. So how will the planned obsolescence of 4K TVs affect the OTT market? I mean, if I'm Netflix and Amazon and Hulu, I mean, I'm still full speed ahead. I want to create video that people can watch, and I don't really care that their TVs are going to be obsolete. And I don't know, for consumers, again, I'm not buying. I don't know how much that's going to freeze the market. I noticed, I live in a very small town in Virginia, and Walmart had their first 2 4K TVs. One was $600 and one was $1,200. So, they're out there, they're inexpensive, they're in small town distribution. I don't know how much the obsolescence is going to affect consumers. I do know the content side, if Netflix has to re-encode movies because the technology changes, it's going to cost them around $300,000 total. And that's for, that assumption is a 4K movie encoded to 9 adaptive streams, and the cost per hour I came up with is around $25 an hour. So I thought the number was going to be much bigger. So I don't see it as a big bar for the publisher, but I think the looming obsolescence of 4K TV sets could really stilt the purchases, especially as the updates, the new technologies get closer and closer. Any questions about this? It's dense stuff right after lunch, but I guess the high-level point is, that Netflix doesn't care. If the standards change, they can spend, $300,000 to update their title. And then there's the deliverability issues. Netflix says we need 25 megabits per second to stream Ultra HD TV. Who here feels confident enough they can get 25 megabits a second? I mean, if you're in a big city, in some areas you can. I can probably get 15 to 20, so I'm pretty close. But still, it's a pretty big number. And if you've got multiple people in the house, that number degrades. So it's still a pretty big chunk of downloadable content. In the Akamai State of the Internet, this is something they track every quarter. The average download speed in the US, and we're actually ranked 16th, is 11.1 megabits per second. So clearly the average consumer is not going to be able to download 4K content. There's going to be pockets of primarily big cities that will be able to do so. And then this was a report put out by Streaming Media just a couple of days ago, the Unisphere Research Report, OTT Video Delivery. And they specifically asked OTT publishers, what's your biggest problems? And the biggest problems that they had, and presumably a lot of this is for HD content, not UHD content, and they talked about quality of service and bandwidth limitations being the first and second biggest problem they faced. So you've got to think that, while everybody likes the potential profitability of 4K, A, they're going to have trouble delivering it. B, it's going to cost a lot more to deliver it because obviously it costs more to deliver a 16 megabit per second file than an 8 megabit per second file. And I think it's a big concern. So I'm not a big, I hear what Netflix says, I hear what Amazon says. I think it's a very small market. God bless them, chase it. That's what they should be doing. But in terms of the general market as a whole, I don't see 4K HEVC as a huge market. Okay, so that's kind of my snapshot on where we are, and I think OTT is good with all the limitations about 4K sets. I think streaming to computers and mobile devices is really just at the nation stage. I think it's almost non-existent. So if you still want to produce HEVC video, that's where we're going with this next part of the conversation. So there are a number of different encoding vendors out there with HEVC codecs. X.265 is going to be very significant. That's the one that companies like Telestream is integrating into Episode. Some companies like Elemental and other companies will create their own HEVC codecs, but you're going to see a lot of concentration around X.265 and main concept. So I'm going to cover a selected group of encoding parameters, and we're going to see how they affect both encoding time and encoding quality. And I just wanted to make the point with this particular slide that every vendor is going to offer different access to different encoding tools. Elemental is very famous for limiting the tools that people can access. They say, here's a good preset, use it. It'll do a very good job with a broad range of content. Other vendors will give you access to very, very discrete tools and let you, tweak yourself to death if that's the direction you want to go in. And then again, what I did two or 3 years ago, whenever I did encoding comparisons, I'd encode the files and I'd put them up next to each other and try and make some kind of subjective evaluation. That was very difficult to do, especially in volume. So I've got the Moscow University tool. We talked a bit about that a few minutes ago, and I rely heavily on the video quality metric backed by subjective analysis. So I look at the video quality metric, I look at the files, play them back in real time, make sure there's no obvious motion-related issues, and then I kind of draw my conclusions. So the first thing I wanted to talk about is and it sounds kind of silly, but I think choosing the right data rate is the most important. Whenever you're choosing a file, you end up choosing your resolution. You know what that's going to be. Choosing data rate is the single most important factor in terms of overall quality. I mean, it makes sense, but we kind of forget about that. And we also don't really know how much additional quality affects, or how much additional data rate affects quality up and down through the entire range of the potential reality. So this is 1080p encoded on a range from 2 megabits per second to 7 megabits per second. And what I tried to do here is, again, lower scores are better. So the 0.805 for 2 megabits per second represents about 19% of the total quality of 0.444. that make sense? So if you look at the range of quality from the best to the worst, and then you divide it up into chunks, you see that 2 megabits per second is about 19% of the quality. 6.5 megabits per second is 98% of the quality. So as you go up here, you grab more and more quality. And the reason I did this was it's going to make more sense looking at this particular slide. And so this shows you, here's the Vqm score. So this is the video quality metric score, and that goes down as the data rates increase, and the data rates are here. And then here we see the percentage of maximum quality. So this is 19%, and then for another half megabit per second, you go from 19 to 40. So you get 21% of additional quality. And then here you go from 40 to 55, that's 15%, and you start to see the slope slow down. So you go from 55 to 66, that's 11, 66 to 75, that's 9. So it's a diminishing returns. You can throw additional data at the file, but the benefit gets lower and lower and lower. And as a producer, you need to make the decision where you want to cap that off. You always get more quality, but you get more bang for your buck down here than you do up here. Does that make sense? Any questions about this? So first thing is pick a data rate. The second thing is pick a preset. So a preset in the context of X.265 is a single preset that you choose that controls a range of parameters. So you don't have to worry about setting B frames or setting any number of different discrete parameters like those shown here. Basically, you choose a preset, which are represented on the top of the chart here, and then those are the parameters that are changed in the encoding. So basically, what the X.265 producers tried to do is give you a range of relevant presets so that you could say, well, let me use this. This gives me the best balance of quality and encoding speed. Okay, and then the big question is, well, how much quality, how much encoding speed? So what I did here was I used the different presets, and I normalized both the quality and the time as 100%. So 100% of the time is the bottom preset. That's placebo. So that, in raw numbers, I think that was 350 seconds for a 5-second file. It took a very, very long time. So that's 100%. And then I normalized for that 100% in time and in quality. And that gives us the ability to kind of trade off quality versus time in this particular chart. And this is a pretty sexy chart, right? But this kind of tells you that this is the curve of time, and this is the curve of quality. So this tells you at this medium preset, which is the default preset, you're getting 83% of the quality in roughly 4% of the encoding time. So that seems like a pretty good investment of encoding time. On the other hand, if you go from here to here, if you go from very slow to placebo, you get no benefit, but you're increasing encoding time by 40-something%. So the preset that is pretty much standardized is going to be the medium preset. When I do most of my encodes, I'm not a volume shop. I mostly focus on either slower or slow. But you see, you're leaving some quality on the table. If you lose slow, you're leaving roughly 8% of quality on the table. Slower, you're getting 90% of the quality in roughly 40% of the encoding time as compared to placebo. So, and then a couple of, just a fun, I'm pretty big on basic encoding parameters. I think you need to get those right, and you need to know how they impact. And one of the ones that has been frustrating for me, a lot of people came from the broadcast world. Broadcast world, it was one keyframe every 15 frames. So, what worked for MPEG-2 should clearly work for H.264. So you see a lot of people still encoding, 2 keyframes a second or 1 keyframe a second. And I wanted to kind of quantify whether that was a good strategy. So I encoded, the same file, same parameters, same data rate at keyframe intervals of 15 frames, 30 frames, 60 frames, 90 frames, and 120 frames. So on the left is HEVC, and I got some funky results. And I got the X.265 codec literally Friday morning. So I didn't have a chance to run the test, look at the results, rerun the tests. I'm kind of in the first set of that feedback loop. So we saw quality, again, lower quality is better. So we saw the quality increase 4% from 15 to 30. We saw it increase 11% from a keyframe every second to a keyframe every 2 seconds. And then we saw the quality drop, get worse with the keyframe every 3 seconds. And clearly that's unintuitive, shouldn't be what's happening. So I'm calling a mulligan, and I'm gonna do that one over this weekend, and I'll repost these results to my website. So and I put up the H.264 results here because we see a continual increase in quality as we get longer. The increase drops. We see from 1 second to 2 seconds, you get 7%. 2 seconds to 3 seconds, you get 6%. And then 3 seconds to 10 seconds, you get only an additional 2%. So we saw the benefit start to level out, but you still got more of a benefit from longer keyframes. So I'm going to go back and test the HEVC, and I'll repost this on my website. But if you've been encoding in the 1 second to 2 second range, it's time to reevaluate that because I think you can do better with the longer keyframe interval. And then looking at main concept, they don't use presets. They use what's called PQ values. So they go PQ value is 1, and that gives you the fastest encoding speed, lowest quality, and up to a PQ value of 30, that gives you the longest encoding time, best quality. And again, what I tried to do was normalize here for 100% speed, 100% quality, and this kind of delivered this chart. And we see, it's a lot different than we saw with X.265. Here, with a PQ value of 22, it's 2% of overall encoding time, and you're getting 93% of overall quality. So that tells me that if I'm encoding with main concept, I'm probably not going to increase my encoding time by a factor of 15 to get 5% additional quality. So this was kind of a nice fun series of tests to run just to understand how you were going to set this most important parameter for trading off quality versus encoding time. And then there's a couple of other features I wanted to look at because they were available on on both platforms. Things get a little bit confusing because they work differently with this one in main concept and X.265. We're not at X.266 yet. Wavefront parallel processing is a feature that improves encoding speed and decode efficiency, but can cost you in quality. And what was interesting was that main concept disabled wavefront parallel processing, and that was a good decision for them because these I did with individual test clips, so 6 5-second test clips, actually 7. And so the increase in encoding time was 22%. The increase in quality was about 0.2. So increase in encoding time, 23%. Increase in quality, 0.2%, not worth doing. And then X.265 enables wavefront parallel processing by default. And that turned out to be a good decision for X.265 because you decrease encoding time by 65% and increase quality by about 4%. So interesting that one parameter worked one way for main concept and worked differently for X.265. And then sample adaptive offset is a filter applied after the standard deblocking filter. It's designed to increase picture quality and reduce banding and ringing, but it does slow encoding speed. And what I saw here is that encoding time is about the same, but the quality increased significantly with main concept. So with main concept, you want to enable this, and very little encoding time difference here, and the overall quality actually decreased. So I would disable sample adaptive offset in X.265. But we're getting into the weeds. Fortunately, this is our last slide. So let's go into questions. Any questions?
Well, I've got a follow-up from earlier. I bothered to Google. Yeah, Snapdragon 805 does support HEVC. It's in the Samsung Galaxy 5S as well as Nexus 6. So there are HEVC hardware accelerated mobile devices.
Okay. Anybody have one of those yet? I kind of wonder where you get content, but I mean it's been coming, and it's no surprise. Any other questions?
The quality metrics that you show in the chart, how dependent is that on content? Somehow analyze that out.
So how dependent is the quality metric on content? It's very dependent on content. So, and that's why I did 3 different test clips. So for the overall VP9 versus X.265, I looked at 3 different types of clips: one animation, one movie, one kind of real world. Movies tend to have a lot of depth of field where the star's in focus but the background's blurry, and I was concerned that would make things easier to compress and might not be representative. So I looked at 3 different files, and then for some of the tests you saw I looked at 7 very short files just to kind of look at how those technologies worked on those particular files. So it's very content dependent. And hopefully I presented a framework where you can run some of the tests yourself, because if you've got an idiosyncratic piece of content, if you're doing webinars all day, just a talking head, your encoding parameters really should be differently than somebody who's encoding a soccer match, because you do want to, 2-pass encoding is critical for a soccer match. It's irrelevant for a talking head. A lot of the benefits we saw in terms of data rate producing a benefit would flatten out a whole lot quicker for a talking head than it would for a video that had a lot of motion, a lot of detail, where additional data really has some benefit. So all encoding decisions are pretty idiosyncratic.
If you're not doing HD video, then you don't have to really worry about it.
Say it again?
If you're not doing HD video, then is there really any benefit to encoding this way?
Good question. So if you're not doing HD video, do you care about this? Were you here the whole time? I hope not. I mean, I think from a bandwidth savings perspective, you'll see the most bandwidth savings from 1080p video, and it goes down and down and down and down and down. So I think you probably would see a little bit of benefit with HEVC, but nowhere near what you'd see with, with 1080p and obviously, 4K. So yeah, if you're doing SD video, I wouldn't see this as a priority in my development cycle. Anybody else? I'm leaving town right after this. This is your last chance to. Okay, thanks for your attention.